Welcome to OmegaCodex. Today we talk about the Azure outage which happened on 18th July and impacted a wide range of services in Central US region. If you were one of those who has services in this region, then you very well know how severe the impact was. When relying on cloud services, understanding what transpired during this outage is crucial for enhancing the resilience of your own systems. Between 18th and 19th July, multiple Azure services experienced disruptions leading to widespread connectivity issues and service failures across various sectors. In this video, we'll break down exactly what happened, the critical lessons we can learn, and most importantly, the steps we can take to ensure that our systems are better prepared for such incidents. Stick around as we explore these key areas, and by end of this video you will understand the incident in detail and also walk away with actionable insights to strengthen your cloud infrastructure. So let's get started. Let's dive into the heart of the matter. What exactly happened on 18th of July that caused a widespread outage? The incident began around 9:40 UTC and persisted for almost 24 hours, severely impacting multiple Azure services in the Central US region. The root of the issue lay in Azure's virtual machine infrastructure. Most virtual machines rely on a persistent disk, which are backed by Azure storage. As part of Azure's security protocol, only a specific network addresses are allowed to access these disks. These addresses, known as an allow list, are regularly updated to reflect the changes in the infrastructure, such as addition or removal of VM hosts. On 18th of July, a routine update to this allow list went wrong. Due to a recent change in network configuration, some file servers which store critical data needed for the update became inaccessible. This led to generation of an incomplete allow list, which was then distributed across all storage units in the Central US region. Now, this incomplete list caused the storage servers to start rejecting disk access requests from certain virtual machine hosts, leading to a widespread unavailability of virtual machines. Since many Azure services depend on these VMs to function, the outage quickly spread across the region. The outage had a cascading effect, impacting numerous services across Azure. Now let's break down what affected and what didn't. The outage severely affected services that rely on virtual machines and Azure storages. These services included like Azure SQL Database and SQL Managed Instances, where customers faced significant connectivity and service management failures. Azure Cosmos DB, with around 50% of VMs running on these services in Central US region, went down, leading to a drop in request success rates. Azure DevOps, which saw disruptions not only in Central US but also in other regions due to some data and metadata residing in this impacted region. Microsoft's own cloud services such as Office 365 and Dynamics 365 were also affected because of their dependencies on Azure services in this region. Additionally, services like Azure Resource Manager, Azure Net App Files, and Privileged Identity Management were impacted due to their resilience on the affected Azure infrastructure. Interestingly, not all services were affected. For instance, storage scale unit, hosting, premium V2 and ultra disk offerings remain unaffected. This means any virtual machine utilizing these specific storage offerings did not experience the same issues. Cosmos DB accounts configured with multi-region writes or an active mode or with single region write outside Central US also were largely unaffected, maintaining their availability by redirecting to other regions. Also, databases with session and lower consistency settings managed to avoid major disruptions as they could maintain availability by directing traffic to other healthy regions. As the outage unfolded, it became clear that the issue was widespread and complex, affecting not just isolated services but entire ecosystem within Azure. While some services managed to weather the storm, many others experienced significant downtimes, demonstrating a far-reaching impact of such a technical glitch. Now, as an architect or an engineer, we can face such situations. The cloud providers will take all possible steps to reduce impact and recover the services ASAP. But we should also design our systems such that they are resilient and available during such incidents so that we have minimal impact. During the outage, several critical services were impacted, causing a widespread disruption across Central US region. Let's explore specific strategies which we can implement to make them more resilient. Azure SQL Database and SQL Managed Instances were among the hardest hit services. Connectivity issues and service management failures affected numerous databases, with some requiring manual intervention to restore availability. For architects, this highlights the importance of a robust DR strategy. Ensure that your SQL databases are configured with geo-redundant backups and that automatic failover policies are in place. Now, by using failover groups, you can seamlessly redirect traffic to a secondary region if the primary region becomes unavailable. Monitoring is also crucial. Set up real-time alerts for metrics like connection failures, high latencies, and failed login attempts. This allows your team to respond immediately to any signs of trouble, potentially mitigating the impact before it escalates to a full-blown outage. Now, Azure Cosmos DB users experience significant disruptions, especially with those with a single write region in Central US. For Cosmos DB, one of the best strategies to ensure resilience is to configure your database accounts with multi-region writes, also known as active-active replication. This setup allows you to maintain availability even if one region fails, as the traffic can be automatically redirected to other healthy regions. Additionally, consider the consistency levels that you can use. While strong consistency offers strict data guarantees, it can lead to higher latencies and availability issues during a regional failure. For many applications, using session or lower consistency levels can produce a good balance between availability and performance. Make sure to also configure your SDKs for resilience, enabling automatic retries and failovers in case of regional issues. The Cosmos DB SDK is quite efficient in doing this. Finally, regularly test your failover processes. During the outage, a small percentage of Cosmos DB accounts required manual intervention due to the issues in the failover workflow. Now, by conducting regular drills, we can ensure that our failovers are smooth and our team is ready to handle any unexpected complications. Azure DevOps also was impacted, particularly because some customer data and metadata were stored in the Central US region. This incident underscores the importance of understanding where your data is stored and how it could affect your DevOps workloads. While Azure DevOps doesn't offer you a regional affinity, understanding these limitations can keep us prepared about the risks which we need to accept as part of our system. Monitoring and alerting of pipeline failures, build issues, and deployment problems can be set up to trigger immediate investigation and remediation. Enhanced monitoring is crucial. Implement comprehensive metrics that can quickly detect issues in your data and control planes, and correlate these with service health to trigger appropriate failovers and mitigation. This can help you respond more effectively during incidents. Moreover, refine the logic that detects and classifies impacting events within your services. By doing so, you can ensure timely detection and more accurate responses to potential issues, reducing downtime and improving the overall resilience. By focusing on multi-region setups, robust DR plans, proactive monitoring, and thoughtful architecture, we can design systems that are prepared to handle even the most unexpected events. As architects, our goal should always be to minimize downtime and ensure that our services remain reliable no matter what challenges arise. Thank you for joining me in this video. If you found this video helpful, please consider subscribing to the channel for more insights on cloud architecture and resilience. Don't forget to like this video and share it with others who might benefit from these insights. As always, I look forward to hearing your thoughts and experiences in the comment section below. Until next time, keep designing with resilience in mind. Adios.